SAC raises funds for a library by running a game where players spin a needle. The final position of the needle results in an outcome where a player wins or loses money. The outcomes with associated probabilities are shown in the following diagram. So as we can see, here is the needle thing that is spinning around. And notice, some of these are wins, some of these are lose. So you win $5 with a 40% chance, right? And the rest of them actually are lose $8 with a 10% chance, lose $5 with a 20% chance, and lose $10 with a 30% chance. Okay, so that's that. See, so then they tell us that let X represent the amount that a player of this game wins, and for part AI, we need to find the expected value of X. Okay, this is a classic. In my experience, they tend to ask expected values like at least once, either in paper 1 or paper 2. They ask it at least once. Okay, it's a pretty common sort of thing that you do have to know. And if you pop out with your formula booklet and you go to expected value, it doesn't help you very much, because you look at this expected value formula, which is right here, and you look at it and you say, I don't understand this. Okay, and I'm gonna be honest, this isn't very intuitive. Okay, so let me try to break it down for you. Okay, think of this X, okay, as like, it's sort of like the outcome. Okay, so this X is going to be like the outcome, which for our context, it's going to be win or lose. And this whole thing, which I am now putting in whatever, in green, okay? Damn it, I don't think this is going to work. Nope. And the thing that I'm now putting in green, this whole thing, okay? Because it has the big P, okay? It's going to be the probability of that outcome. All right. And this last symbol at the end, or at the beginning, sorry, this should be a symbol that you sort of recognize. This is like a, I know how to say in Spanish, una sumatoria. In English, I don't know if it's summation or what. The point is, it's like you're adding all of them. See? So this is basically telling you, you will be adding all of the multiplications between outcome and probability of that outcome. See? So for expected value, all you have to do is multiply the outcome of a single thing times the probability of that single thing and add all of them together. See, that's basically what's happening here. And so having that in mind, now that it's a little bit more clear, for the expected value in this case, right, as I said, it's the outcome times the probability of that outcome. So in this case, winning $5, right? So winning $5 times the probability of that outcome, which is 40%. How is 40% as a decimal? 0.40. Okay, so, and all we have to do, because it's a summation, is add all of these together. So this is the, let's associate some numbers to it. See, so this is for the first one, right? This is for the second one, third one, and fourth one. So for the first one, it's right here. See? Then we have to add onto it. This is still the same formula. I just kind of ran out of space. We have to add onto it the second one, which is going to be lose 8. So it's going to be negative 8 times a 10% chance, which is going to be 0.10. See? So this right here is going to be the second one, right? Then we still have to add for the third one, but the third one is lose 5. So yes, we're adding, but instead of being a plus 5, it's going to be a negative 5. That times the 20% chance, which is 0.20. So that's for the third one. And then for the last one, for the fourth one, we're going to add again because it's still a summation, ¿cierto? Outcome times probability. Outcome is 10, negative 10 because lose, and probability being 30, 0.30. Ladies and gentlemen, from here we have the fourth one, okay? What are the observations that I can do from here? Take a quick look. The ones that are win, you're multiplying by a positive number. And the ones that are lose, you're multiplying by a negative number, see? And I know that some of you are probably thinking, why do you have plus times a negative, see? Technically, I could have just left all of these as negative and forget about it. See? But for me, in my mentality, it's very important that I follow the procedure correctly. And for me, following the procedure, if it's a summation, I'm going to put pluses all over it. See? And I'm going to put in parentheses the negatives just so that I remember and I don't mess up. And I, end up with a negative if I end up with a negative, end up with a positive if I end up with a positive. The biggest idea I can share from here is that notice all of these, as I mentioned earlier, are your outcomes. So all of these, are outcomes. And I'm putting it in blues, much like how it's in blue here. And all of these, which I'm putting in dark green, all of these are your probabilities of each of these outcomes, which is the same probability that I mentioned earlier. See? So expected value is not that hard. You just have to sort of have the intuition that it's just going to be the outcome times the probability of that outcome and all of them being added up together. Dale? If it's win, you're going to be adding your dollars, and if it's lose, you're going to be subtracting your dollars. Makes sense, ¿cierto? So that's probably as clear as I can leave it. And so for part AI, if you put all of this into your calculator, you end up with something that we're about to discover. See, so all of this into your calculator. If you just give me a moment, make sure that your calculator actually has battery in it, because this guy is, falling asleep. Yeah, there we go. See? So, just add all of these together. See? So you're going to end up with the first one, which is 5 times 0.40. Plus the second one, which is -8 times 0.10, plus -5 times 0.20, plus -10 times 0.30. Go ahead and press enter, you end up with -2.8. So I was about to explain what this means, but that actually has a lot to do with part 2. Okay, so for part AI, we just found that the expected value of x has to be -2.8. Okay, now what does this mean? And this is part of interpreting our answer from part AI. This means a couple things, but the general idea is that if you were to play this like a lot of times, on average, you're going to be losing -2.8. Okay, so on average, you're going to be losing. And this also has a big implication, which is something that shows up all the time in these exercises, and I'm going to mention right away. Usually when they talk about expected value, the curveball that they throw at you, the specific thing you have to know, is being able to tell if the game is fair or not. If a game is fair, ladies and gentlemen, if a game is fair, then the expected value has to equal to 0. Okay, that means that, I don't know, if you and me play, on average, we're both gonna, sort of like win and lose the same amount. ¿Cierto? Like if we play 4 matches, I win the first 2, and then I lose the next 2, I end up at 0. Fair is fair. ¿Cierto? So that's sort of like the idea. Oh, and I end up earning in total like 0. ¿Cierto? It's not so much winning the first 2 and then losing the next 2. It's more like looking at all my earnings, I end up at 0 after all the matches. Okay, that is how you define that a game is fair. That's also why the casino always puts these weird rules so that they earn a little bit more than you, and enough people go and they end up making a lot of money. See, so all the expected values for casinos end up being negative. If it were positive, it's also not fair, because that means I'm winning a lot. ¿Cierto? So for a game to be fair, expected value has to equal 0. So that is one interpretation that you can give. The other interpretation that I also mentioned was something like, I don't know, on average, people lose a lot of money, ¿cierto? On average, people lose $2.8 per game. On average, this or that. But notice, there's something very important that I'm doing here. All of my answers, pretty much all of them, are starting with the words on average. They're starting with the word on average because part of the interpretation of the expected value is that this is sort of like a long-term implication. If the expected value is -2.8, then usually you're gonna be losing negative $2.8. It doesn't mean that every single time that you play you lose negative $2.8. It's a long-term sort of thing. It's an on average sort of idea. And if we actually look at the answer key over here for part A double I, ¿cierto? Which is right there. I don't want you to, I mean, you can take your time and read all of them, but the main idea is, look at this, ¿cierto? Here, for this first bullet point, they say players will lose $2.80 per game, which is the same thing that they say here. Now, the one up top, which I'm now putting in red, ¿cierto? They accept it, and the one on the bottom, they do not accept it. Do not, and the ones up top you accept, the ones on the bottom you do not accept. Why do we not accept the one on the bottom? Because, you don't mention that it's on average. You don't mention anything about being long-term, ¿cierto? So it's very important that for the interpretation of expected value, we talk about on average and long-term, etc. See? The same sort of example happens down here. It's not enough to say that it's not fair. You have to, okay? You have to include the whole thing before it, which is the expected value does not equal to 0, so blah, blah, blah. See? For the interpretation, you gotta give a reason, and you have to leave very clear that you understand it has to do with the long-term, on average sort of thing. Okay? It's interesting though, here, they do mention on average, but they don't specify how much. It's like, oh, on average, players lose money. Okay, you're right. On average, players will lose money around 2.80 per game. Okay? So, what's the main idea you need to get from this? Be as specific as you can to get this point. And also, hopefully, mention at some point that we're talking about on average. We're talking about long term. We're talking about something of that sort. So, a little bit of a long monologue there, but I think it was worth to leave clear how expected value is interpreted, how it works, etc. So that is for part A. Then they tell us that to encourage a person to keep playing this game, Zach increases the winning price for the second game they play from $5 to $6. For each successive game they play, the winning price continues to increase by 1. And our good old friend Emily plays K games, and they tell us that the Kth game is fair, and for part BI we need to find the value of K. So, a little bit hard to interpret, but if we take a moment and read it again, because for these exercises that are loaded with information, you should be reading it once or twice. I mean, twice or thrice, better said, not just once. They tell us, Zach increases the winning price for the second game from 5 to 6. And for each successive game, the winning price continues to increase by 1. All right, Zach is entirely an entrepreneur. He's trying to convince us to play his fishy game and take all our money. Zach is probably going to be a politician. Anyways, point is, this $5 winning up here for the first one, ¿cierto? This $5 winning that's up there, see? It's basically like win 5 first game. And then it's going to be win 6 second game, which is this part here, ¿cierto? The second game, it increases from 5 to 6. And we're talking about the winning price, and there's only one winning prize, ¿cierto? The other 3 are lose. And so first game, win 5, win 6 for second game, and win 7 for third game, see? And if I kept going, technically I have win 8 for the fourth, and win 9 for the fifth. Okay, that's the general idea of like what's happening here. Okay, the hard part is expressing this in terms of math and stuff like that, ¿cierto? So Emily plays K games, and the Kth game is fair. Find the value of K. Now, my expected value formula, let's rewrite it, see, for part AI. So before, ¿cierto? Before we had this, 5 times 0.40 plus negative 8, I think it was. See, negative 8 times 0.10 plus negative 5 times 0.20 plus negative 10 times 0.30. Yeah, this, ladies and gentlemen, is like what we had for part AI. See? So for part AI, there wasn't anything about the second game increasing and the third and etc. and blah blah blah. This is like for every single match. See? For part BI, this expected value formula needs to change, but just a little bit. ¿Cierto? Think about it this way. The winning money, this part here, which I'm putting in yellow, this is for winning, right? The rest of them are for losing, and what they're telling us here is that the winning price is what's going to be changing. See, so this part of the formula has to change, and the rest is actually going to remain the same. Okay, the rest is going to look exactly the same, and actually give me a moment just so that I can write it down. ¿Vale? So the rest is going to remain exactly the same, but the winning part is what we have to sort of express the K somehow. And honestly, I think it's better if I just write how it should be, and then you can sort of, and then we interpret it. Right? You do need to be kind of creative for this and find a way to express this in terms of math. Right? So, think about it this way. We still have a 0.40 probability, ¿cierto? So that is going to stay the same. But the earning 5 needs to change over time. So, it starts with 5, ¿cierto? Because that is the first game. How do you express the second game? Okay, technically, I could express the second game as like just +1, because 5 plus 1 is going to give me the 6, right? But then how would I express it for the next game? I would have to put another +1, see? And what decides if you put a +1 or not? The amount of games you've played. Okay, so that means that technically what I need to have here, ¿cierto? Is K is going to be my amount of games. We're going to have it to -1. And I'm pretty sure that works. Just give me a moment to think about it. Okay, perfect. This works. See? Because think about it. If you have that K equals 1, you're going to end up with 5 plus 1 minus 1, which ends up giving you 5 plus 0. So you still end up with 5. See, so for the first game, you actually end up with the formula up top, which is, for the first game. Makes sense. And in this context, if you go ahead and plug in K equals 2, what you actually end up with is 5 plus 2 minus 1, which is the same as 5 plus 1, which gives you 6. So it makes sense. On the second game, as they say over here, the winning price goes from 5 to 6. So boom, makes sense. And just to check if this pattern is going to keep working, for the third game, I should be winning 7. ¿Cierto? Makes sense. I should be winning 7. So if I go ahead and plug in K equals 3, you end up with 5 plus 3 minus 1. And that is what ends up giving you 5 plus 2, which gives you the 7 that we talked about earlier. See? Now, why did I show you these steps that I'm now putting in pink? Not only because it's important to check your work, but also because for an exercise like this, you will probably end up like guessing and checking. See? It's very hard, and I know it's hard, ¿cierto? I know it's hard. I know it's hard to come up with this, ¿cierto? And so on the one hand, you can study it, look at this example, understand the intuition, etc. But the day of the test, I mean, unless you're very sure about your math skills and you're also very good at math, como que, you should probably double check, see? And you're probably gonna end up guessing and checking and seeing what works, okay? So I invite you to check your work, and part B is definitely hard, ¿cierto? So I, back in my day, probably would have ended up guessing and checking here or there until it worked. And I hope I shared some intuition of how it sort of like should be, see? And if I go ahead and check the answer key over here, it's right there, see? Here they multiply by 1, which doesn't really change anything. I mean, this is what we had, ¿cierto? It's the same thing, ¿vale? So, that being said, we just found out the answer for part B. I mean, not the answer for part B, but the correct approach. So now that we successfully expressed um, you know, how to have the winning price increase over time, what we can do now is come back to reality and read again that for part BI, we need to find the value of K. Now, Emily plays K games, and the Kth game is fair. And I did mention earlier that for a game to be fair, expected value equals 0. So, if expected value equals 0, that means that this whole thing equals 0. So I end up with 0 equals 5 plus K minus 1 times 0.40 plus this whole thing that I'm putting now in red for lose. See? Remember that all of these are lose. So how much is that? Let's actually just find it out right away. How much is that? Go ahead and turn on your calculator, make sure it works. I basically can just take all the parentheses with negatives and just erase the part that's positive. See? So all the things in red are what I have in my calculator right now. Go ahead and press enter. I end up with negative 4.8. See? So this is my current scenario. 0 equals the thing in positive with the K minus 4.8. So if you want to get K alone from here, what I would suggest is first adding 4.8 to both sides. So you end up with 4.8 equals parentheses 5 plus K minus 1, parentheses 0.40. See? Now the K, notice it's it's inside two parentheses. See? So it's actually legal if I go ahead and divide by 0.40, which is the parentheses on the outside. That it? So this goes away with this. 4.8 divided by 0.40 gives us 12. So 12 equals 5 plus parentheses K minus 1. And from here, it's, straightforward. You do minus 5, minus 5. That gives me, how much does that give me? 7. So 7 equals K minus 1 plus 1 to both sides. K equals 8. So that means that on game number 8, we have a scenario where the expected value is 0 and the game is going to be fair. So for part BI, finding the value of K, we just found that K equals 8. And just so that you believe me, it is right over here. That it? So that is for part BI. For part BII, we need to explain why Zach expects to raise money from the games Emily plays. So think about it. We found that, like on the first game, because this is for first game, right? So first game, the game is unfair. So that means that for the first game that Emily plays, the game is unfair. She's on average gonna lose money. And on the 7th game, the game turns fair. So that means that everything in between, the 2nd game, the 3rd game, the 4th game, the 5th game, the 6th game, and the 7th game, Emily was losing money. Emily was losing money until the 8th game. On the 9th game, it's the first time that you have a positive expected value. On the 8th game, the game is fair. They're both at 0. And from the 7th game to the 1st game, Emily is losing money. So why does Zach expect to raise money from the games Emily plays? Because the expected value of the first 7 games is negative. Because the expected value of the first 7 games is negative. So someone please call Emily and tell them to dump their toxic boyfriend that is stealing money from her with this expected value thing, whatever, okay? Point is, that's the reason, see? Not toxic masculinity, it's just, an unfair game. Anyways, we come back over here, and that is exactly what they say. For each and pretty much all the first 7 games, there's a negative expected value going on, see? Notice this is a reasoning point. You do have to express in words a little bit, ¿cierto? And hopefully give this, ¿cierto? The expected value is negative, and we're talking about 7 games, see? Anyways, that would be for part BII. Number 12 is not super hard, but you do need to have very clear how the expected value works. See? And please keep in mind the expected value usually comes hand in hand with someone asking whether the game is fair or not. Okay? Whether the game is fair or not is a classic when dealing with expected value problems and probability and stuff like that. Okay? Anyways, that would be for number 12. And what can I say? I hope it helped.